Algebra 2, we are continuing on with trigonometric identities and proving things. Today it's just identity proofs, and we're going to probably develop some things, some new identities together. Alright, so let's look at this table first. We've seen that sine alpha plus beta is not equal to sine of alpha plus sine of beta. So we're actually going to work at developing something about sine alpha and beta. It says, what is sine alpha plus beta? Begin by completing the following table. For this example, they've given us all of our pieces and parts, sine alpha, sine beta. They've added them. They've done sine alpha times sine beta, or cosine, sorry, given us a lot of pieces. So let's actually work through filling out the rest of it. Hold on. So this is going to be a little small for you to see, but I wanted to grab these values so we didn't have to refine them or recalculate them. You may have them memorized, which is awesome. Alright, so let's start. We have, we're trying to find cosine alpha times cosine beta for pi over 6. So right here I have cosine alpha is 1/2, cosine beta is 1/2. That gives me 1/4. Now it's really small for me to write in, sorry. Sorry, I took a little break. I found a mistake in the curriculum. These right here are incorrect, which hurt me right up here. So I'm going to use this table to help me up here. If we see cosine alpha times cosine beta, that's square root of 3 over 2 times square root of 3 over 2, which gives me 3/4. And then cosine alpha times sine beta, I've got cosine alpha is square root of 3 over 2, sine beta is 1/2, so that way I have square root of 3 over 4. Okay, I'm going to go ahead and fill in the rest of the table and be back, but I need you to look for patterns, okay? See if we can find any patterns so that we can come up with an identity to help us with the rest of our trig learning. Okay, so I'm talking while I'm writing, but I'm going to go ahead and push pause, and you can fill in your table here in a second. Be right back. I would also encourage you to get your calculator out and crunch a few of these numbers yourself. It really will help solidify what you're learning. I mean, if we see, just looking for some patterns, if I have sine alpha, sine beta, I can add these two angles together to give me all of these values, or I can just take, for instance, sine alpha times cosine beta is 1/2 times square root of 3 over 2, which gives me square root of 3 over 4. Okay, so what do we see here? If we see a pattern, we're looking for one. Those are the same, those are not. These are the same, these are not, and those are not. Still looking for a pattern. I've got duplicates here, duplicates there, equal here and there. That one's interesting. Those are equal. That whole line is equal. That's pretty cool. Okay, this one is, those are the same, those are the same. Okay, write this one down. This is the pattern that we're actually looking for. Sine alpha plus beta equals cosine alpha times sine beta plus, I think that's wrong. I think it's a minus. Let me check. Nope, it's a plus. Sine alpha times cosine beta. So let's see if we can find that pattern up in that top table. Sine alpha plus beta. So sine alpha plus beta equals cosine alpha sine beta, right here, 3/4, square root of 3/4, times, or no, plus sine alpha cosine beta, sine alpha cosine beta. plus the square root of 3 over 4. That gives me 2 square roots of 3 over 4, which is the square root of 3 over 2, which is in fact what it is. Okay, so here is a new identity that we are going to use today. Here we have the next table, which I copied onto the last page, but see if you can formulate a conjecture for cosine alpha plus beta. Okay, we're looking for 1/2. If I add, nope, that won't work. Erase. How about if I take this and subtract that? Nope, that won't work. Sorry, I found another mistake. Makes me wonder how many mistakes are there. If you look at the previous table, the one that we just finished filling in, sine alpha times sine beta is actually 1/4. So if I'm looking for a formula for cosine alpha plus beta, I can do 3/4 minus 1/4. It will work. Let's see. Cosine alpha plus beta is 0, so if I subtract those two, it works. Here, yep, subtraction seems to be the way to go. Cool. So my rule is for cosine alpha plus beta, I get cosine alpha, cosine beta minus sine alpha, sine beta. Write that one down. We'll use it again. Here's a crazy example to come up with our equation in a different way. It's a proof. The proof for addition and subtraction formulas for sine and cosine, they are sort of complicated, so we're going to try to simplify them a little bit. I'm only going to do the proof for the sine addition formula. And yeah, that's all we're going to do during this lesson. So let's go through the steps. One conjecture is that the formula for the sine of the sum of two numbers is sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. The proof can be a little long, but it's fairly straightforward. We'll prove only the case when the two numbers are positive and their sum is less than pi over 2. We have a square here. Well, we have a rectangular shape because we're using 90 degrees or less. So first of all, let alpha and beta be positive real numbers so that they are between 0 and pi over 2, or between 0 and 90 degrees. Letter B, construct a rectangle MNOP such that PR equals 1. The measure of angle PQR is 90. PQR is 90. And RPQ is beta. And QPM is alpha. Okay, that's our figure. Fill in the blanks in the terms of alpha and beta. So the measure of angle RPO, we're going to say that is, we have 90 degrees, or pi over 2, whoops, minus alpha minus beta. Let's look at it. So we have pi over 2, which is 90 degrees, and we're subtracting out alpha and subtracting out beta, and that gives us this angle right here. Okay, that's angle RPO, right there. Now how about the measure of PRO? PRO. Well, I've got two parallel lines here. Let me draw this in and then I'll erase it. I've got two parallel lines here and a transversal. So really, this angle is equal to that angle, correct? Okay, so I can write that that angle is alpha, oh stink, sorry, alpha plus beta. And I'm going to erase those parallel lines. Oh no, I'm not? Aww. Okay, give me a second, I have to redraw that. It worked, I just had to redraw that. Okay, so letters III, therefore sine alpha plus beta equals PO. Let's look at that. We have alpha plus beta up here, because we just did that. And sine of alpha plus beta equals opposite over hypotenuse. So we have opposite over hypotenuse. So sine alpha plus beta equals PO over 1, because my hypotenuse is labeled as 1, or just plain old PO. As I said, opposite over hypotenuse, so PO, the length of PO over 1. How about RQ? RQ is right here. So RQ equals sine of, so if we look at beta, that is opposite over hypotenuse. So sine of beta is RQ over 1. So we can say RQ equals sine of beta. Then PQ is adjacent over hypotenuse, PQ. So cosine of beta equals adjacent over hypotenuse. So cosine of beta. Okay, let's move on. Okay, let's label the angle and length measurements that we just did. So everything that we just did, let's go ahead and label it. Use this new figure to fill in the blanks in the terms of alpha and beta. So first of all, why does sine alpha equal MQ over cosine beta? So look at alpha, MQ. So here's our alpha. Sine is opposite over hypotenuse. So sine of alpha equals MQ over cosine beta, because that's what it is. Therefore, MQ equals, if I just multiply both sides by cosine beta, sine alpha cosine beta. Therefore, the measure of RQN, let's look at it. RQN. Okay, let's look at the angles to try to figure out what RQN is. So follow me. If I look at this triangle right here, inside of a triangle is 180 degrees. I have 90 degrees in alpha. That means this angle right here is pi over 2 minus alpha, right? Because if I add all those together, I would get 180. Pi over 2 plus pi over 2 is 180. A negative alpha and an alpha gives me 180 altogether. So now if I look at this straight line right here, I know this is pi over 2 minus alpha. This right here is pi over 2 because it's labeled as 90 degrees, which means this one left is alpha. So I have alpha plus pi over 2 plus pi over 2 minus alpha gives me 180 degrees altogether. Crazy, I know. So that means that the measure of angle RQN is, in fact, alpha. Moving on to part F. Now let's consider triangle RQN. Since the cosine of alpha is adjacent over hypotenuse, it's QN over sine B. We can say that QN equals cosine alpha sine beta. Label these lengths and angle measures in the figure. I think we have everything pretty much measured, or sorry, labeled. I can label that side. Hold on. That's awful. My pen's just not accurate enough. I just labeled these two sides. We solved that NQ is cosine alpha sine beta and MQ is sine alpha cosine beta. That's all that we've done. Okay, next slide. Okay, since rectangle MNOP is a rectangle, OP is equal to MQ plus QM, right? And we just said that MQ is sine alpha cosine beta and QN is cosine alpha sine beta. So that's what side OP. Therefore, sine alpha plus beta, which we've already had the side of that rectangle labeled, equals sine alpha cosine beta plus cosine alpha sine beta. You have the drawing in front of you, so you can go back and look. So we just proved, okay, that identity. Note that we've only proven the formula for the sine of the sum of two real numbers, alpha and beta, in the case where we're between 0 and 90 degrees. A proof for all real numbers, alpha and beta, breaks down into cases that are proven similarly. to the case we've just seen. Although we're omitting the full proof, this formula holds for all real numbers alpha and beta. Okay, they just did just between 0 and 90 degrees. Now let's prove our other conjecture, cosine alpha plus beta. Again, we're only going to prove between 0 and 90 degrees. This time we'll use the sign addition formula and identities from previous lessons instead of working through a geometric proof. Let's fill in the blanks for alpha and beta. Let alpha and beta be any real numbers. So cosine alpha plus beta equals sine of pi over 2 minus alpha plus beta. Because cosine and sine are complementary, right? So cosine of alpha plus beta is going to be equal to sine of 90 degrees minus alpha plus beta. Okay, complementary. Okay, do a little simplifying. Sine of pi over 2 minus alpha minus beta. That negative just had to distribute through. Gives us sine of pi over 2 minus alpha plus a negative beta. So we have sine of pi over 2 minus alpha times the cosine of negative beta plus the cosine of pi over 2 minus alpha times the sine of negative beta. Simplify to cosine alpha cosine negative beta plus sine alpha sine negative beta. And there we go. I believe this proof is harder to follow. But then we have our identity, which is very cool. All right, let's try some exercise. Formulas for sine of alpha minus beta and cosine alpha minus beta. We're not proving these, we're just going to write them down. In these exercises, formula for sine and cosine of the difference of two angles are developed from the formulas of sine and cosine of the sum of two angles. Okay? So let's rewrite the expressions of sine alpha minus beta as sine alpha plus a negative beta, and then use the rewritten form to find a formula. Okay, so let's go ahead and try it. Let's do sine of alpha plus a negative beta equals, I'm just using the formulas that we just discovered, sine of alpha cosine of negative beta plus cosine of alpha sine of negative beta. That gives us sine of alpha cosine of beta minus, because this negative would carry over, be factored out, cosine of alpha sine of beta. Okay, you can check when we have cosine of a negative value, we have cosine of the positive, but sine of a negative is negative sine of the positive, right? So we have our equation. Okay, we're going to do the same thing for the difference for cosine alpha minus beta. That would give us cosine of alpha plus a negative beta. So we're going to use the equation we've already discovered. So cosine alpha cosine negative beta minus sine alpha, sine negative beta. Simplifies to cosine alpha, cosine beta, plus, because this negative would get factored out, sine of alpha, sine of beta. So we have our two new equations. Okay, we're going to try a few exercises to work through some tangent equations. We're going to derive some formulas for tangent, and then we can start working on our problem set. Alright, so we're working on tangent alpha plus beta. So tan L plus beta, and we can separate that into, we know tangent equals sine over cosine. Sine of alpha plus beta over cosine of alpha plus beta. Now hopefully you're thinking to yourself, hey, I have some equations for those now, let's use them. Yes, we do have some equations, and that's what we're going to use. So I have sine alpha cosine beta, just from what we have already derived. Cosine alpha sine beta. I don't have these memorized yet, so I'm looking at my own notes. Let's see, where are we? There we go. And that's over cosine alpha plus beta. So cosine alpha, cosine beta, minus sine alpha, sine beta. Cool. Now, we need to look at our denominator and our numerator. Let's see if we can simplify this any. No, remember that when we're looking at fractions, this piece is all over this, and this part of the numerator is over that. I can rewrite it, but wow, that would be messy. I can give you something like, if we have a plus b over c, it's the same as a over c plus b over c. Okay, let's see if I can simplify this at all. Well, I think I have to rewrite it. Bummer. All right, I'm going to divide the numerator and the denominator by cosine alpha, cosine beta. So I have sine alpha, cosine beta, divide by cosine alpha, cosine beta. Sine alpha, cosine beta. I was trying to be lazy and not write everything, but I don't think that's going to work. Over cosine alpha, cosine beta. So I'm dividing everything by cosine alpha, cosine beta. Plus cosine alpha sine beta over cosine alpha cosine beta. And the denominator. Cosine alpha cosine beta over cosine alpha cosine beta. Plus sine alpha sine beta over cosine alpha cosine beta. Okay, I'm going to copy this and take it to a new slide. All right, let's simplify this. So that numerator, I've got those that are canceling and those that are canceling. The whole thing and nothing. All right, so let's write down what we have simplified. So for my numerator, I'm left with tangent alpha, because sine over cosine is tangent, and then tangent beta all over 1 minus, I copied that wrong, this should be minus, I'm sorry, 1 minus tan alpha tan beta. So it always looks so daunting, but it always simplifies out into some sweet little equation that's a ton of fun. Okay? Now let's try to derive a formula for sine 2u in terms of sine u and cosine u. So we know that sine 2u really equals, going back to algebra here, sine u plus u, because u plus u is 2u, right? So now we can take this and the equations, the formulas we've learned, and do sine u, cosine u, plus cosine u, sine u. And that is equivalent. These are all the same. 2 sine u, cosine u. That was fun. Now derive a formula for cosine 2u, which equals cosine u plus u. Use those formulas, equations that we've already derived. So that gives me cosine u, sorry, I had to go back and look at my notes. Cosine u minus sine u, sine u. So now we have cosine squared u minus sine squared u. So we have, oops, sorry, cosine 2u equals cosine squared u minus sine squared u. And I can rewrite that because we know that sine u squared equals 1 minus cosine squared u. Sorry, sine squared u is the same as 1 minus cosine squared u because that is in the Pythagorean identity. And that works. So I have cosine squared u minus 1 minus cosine squared u. I've got two negatives there. So distribute that. It gives me 2 cosine squared u minus 1. So minus 1 plus cosine squared u. Those are fun few extra steps. We have our final formula. Very cool. Oh, I added an extra slide. Okay, we should have enough info for our problem set. What I've written on the answer key is we're going to do numbers 4 through 10 all.